Hello and welcome to Mr. Davis's Math Classroom. This is Algebra 1, and today we're going over Lesson 6.3, which is solving systems using elimination. Yesterday we talked about solving systems with elimination, and we just kind of scratched the surface on it. Today we're going to do a little bit more complex types of problems as we do our examples. All right, problem 3. We have negative 2x plus 15y is equal to negative 32. The second equation is 7x minus 5y is equal to 17. In the previous problems that we've done in the previous lesson, the numbers matched up. We had the same number. So when we look at this problem, we don't have any that have the same number, which might lead you to believe that we can't use the elimination method. But just like in the last example yesterday, when we changed the signs by multiplying by -1, we can multiply by any number to make the numbers match up. So what I'm looking at here are my y variables. If I look at my y variables, I notice that I have a 15y and -5. And I know that -5 I can make to -15. So what I'm going to do is I'm going to take these two equations and I want to eliminate the y's. So the question is, what do I have to multiply the bottom part by to make it a -15? Remember, I want it to be a -15 since the top is a positive 15. Right? And the answer is 3. So I multiply by 3. 3 times 7x is 21x. 3 times -5 is -15y. And 3 times 17 is 51. Now that they line up and they have the same number, which are opposite signs, we can add them. Gives me 19x, the y's eliminate, and I get 19. Dividing by 19 on each side, I get x is 1. That's just one part of the solution. Let's take that and let's plug it in for, let's plug it into the bottom equation. All right, so we get 7 times 1 minus 5y is equal to 17. 7 times 1 is 7. Minus 7 from each side. 10. Divide by -5, divide by -5, I get y is a -2. So those two things together is my solution. So that's multiplying one equation of a system. Here's one for you to try. And then multiply one equation in order to eliminate a variable. Okay, on this one says we're going to solve a system by multiplying both equations. So last one we only multiplied once, this one we have to multiply twice. When I look at this equation, I have numbers, none of them match up, and I can't make one into the other. For example, I can't make a 2y into a 3y without multiplying by some decimal or fraction number. So, but I do know that these numbers are very similar or very close to each other, very easy numbers to work with. So what I'm going to do is I'm going to look and decide what number those go into. Now, we can choose to try to make the x's eliminate, or we can choose to try to make the y's eliminate. Does not matter, you'll get the same answer. If I try to make the x's eliminate, I'm going to have to go up to 12, because the 3 goes into 12 and 4 goes into 12. If I try to eliminate the y's, I have to go up to 6, because 2 goes into 6, 3 goes into 6. Will not matter, will not change the answer, no matter which one you do. So how about I eliminate the y's? So we said 6. So I'm going to multiply the top one by 3. 3 times 3x is 9x. 3 times 2y is 6y. And 3 times 1 is 3. Looking at the other one, I want to make those two eliminate, which means I need to make a -6y. Since I have a positive 3y here, I need to multiply by a -2. -2 times 4x, -8x. -2 times 3y, -6y. -2 times -2 is a +4. Let's add these together. I get 9x plus a negative 8x is x. The 6y's eliminate, and then we have 7. So x is 7. This one actually came out pretty nicely because we didn't have to do any division at the end. So x is 7. Last is we have to plug in that 7 to solve for y. So I'll do the top one. I don't think it matters too entirely much, but top one looks good to me. So I plug it in, do my arithmetic. So I get 2y is equal to negative 20. Divided by 2's, y is negative, that's a negative 10. There we go. Negative 10 and 7. So 7 and negative 10. And that's multiplying by both equations. So far we've learned how to do elimination, multiply one equation, and multiply both equations. So it looks like we can do elimination method with most equations. Here's one for you to try. When you finish, or if you have problems, please refer to your notes or the previous problem. All right, problem 5. I want to know how many solutions does the system have? Well, in most cases it's been 1, but we don't know for sure. So let's try this one and see what happens. So it looks like this one we're going to have to multiply by 1 equation because I know that, see, x can go into 2x. All right, so I probably only need to multiply by 1. Top equation does not look like it's going to change. But the bottom equation, I need to multiply to get a negative 2x, right? I want it to be the opposite of my x's, so I want to make it a negative 2x. So I'll multiply by negative 2. Negative 2 times negative 2, negative 2 times x is negative 2x. Negative 2 times 3y is negative 6y. Negative 2 times 19 is negative 18. Now, you've probably noticed something happened here, right? This isn't like normal. Because not only do my x's eliminate, but my y's eliminate, and my constant numbers eliminate. What this does is this makes, if I eliminate everything off one side, I get the number 0. On the other side, 18 minus, or plus a negative 18 is 0. So we get 0 is equal to 0. No variables in my answer. Whenever we have no variables in the answer, we will either have no solutions or infinite solutions. This is a case where we will have infinite solutions. Because if we look, when is 0 equal to 0? 0 will be equal to 0 always. So it's going to be infinite solutions. All right? So, or many solutions. So lots and lots of solutions here. What would it look like if it was no solutions? So, if we had a problem that was no solutions, when we do our elimination, we'll eliminate all of our variables. So we might get something like 0, but it won't equal 0. Okay? Just like in our substitution method, we might get like 0 equals 4. Okay? If 0 equals 4, that never happens, so that means that's a no solution. So that's the difference between infinite solutions and no solutions, the same way that you'll tell us in the substitution method. All right, tell me how many solutions this system has. If you need help, refer to the previous problem. And here's your homework assignment. Enjoy doing the elimination method by multiplying your equations. Thank you.